probability and distributions. So I'm going to be looking over how to use the TI-83, TI-84, and I'll have you go through these calculations using your TI-83, TI-84. So, and if you have any questions, any sort of particular questions that you want me to go over, just tell me and I'll go over those with you. So some of this is, well, I would say all of this is for material that is background for what you'll be doing in your statistics classes, actually more or less from now to the end of the semester. So this is material that is necessary for you to know before you really go and try to attempt the material from now on. So this will help you a lot in actually figuring out what's going on. So, as I said, I'm mostly going to be looking at the TI-83 and TI-84. So the first concept is this idea of a factorial. And so we denote a factorial by this little symbol here, this exclamation point. And so I'm not going to actually define all of these objects. What I'm going to show you how to do is how to find them on your calculator and to have your calculator do them. In your statistics class, you'll actually be, the instructor will tell you, what these are and give you further examples. But what I want to do now is just show you how to find these, to calculate these using your TI-83, TI-84. So 4 factorial. 4 factorial is, well, 4 times 3 times 2 times 1. Well, that's all nice and fine. You can do that in your head. It's a pretty easy calculation, 24. But suppose it was a bigger number, like 12 factorial, 12 times 11 times 10. So it would be, you'd have to multiply 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's a much bigger calculation. Something that I don't want to do in my head. Something that'll take much longer. Matter of fact, it would even take a while. Punching all those numbers into it would be prone to error. So rather than trust myself to type in all these numbers without making an error, let me go and, use a calculator to do this. I want to calculate 12 factorial. So to calculate 12 factorial on my computer, rather than just type in all the numbers, 12 times 11 times 10 times, all the way down to 1, I'll type in 12. And then I will go over to the math menu. And then I'll go over to where it has a fraction, where it has math, where it has probability. And after you look at probability, and I can use these arrow keys here to navigate to probability. And I wanted to do a factorial. So you just click on 4, or the fourth one down. You can either click here on 4, that would take you there immediately, or you could click on these arrow keys to get to the factorial, then hit enter. So if you hit 4, you'd immediately go, or you would need to select and then hit enter. And now, to actually evaluate this number, I would need to click on the enter, and there is 12 factorial. And so I get that in this case. Let me go back to my other. And so you see here, you do the 12 first, you click on the math key, you use your arrow keys to go over to the PRB menu, you find your factorial, and then hit enter. And so in this case, my 12 factorial was found to equal 47,900, 1,600. So that would be 479,001,600. Okay. Oh, well, let me do 25 factorial on my calculator. And so let me go over. Oh, and let's stop. Factorial is 1.5512. No. 112.1.004. Then it said E25. So what that means is that I should actually be moving this decimal place 20 places to the right. Or if I wrote this in, of course, this is an exact, it's an approximation, but well, in statistics, we always write equal, even if we mean approximation. So really what this means is times 10 to the 25. So on your TI-84, TI-83, this weird sort of E25, that means scientific notation. Okay. So let's do another one on our calculator. So get out your calculator and let's figure out, let's say 31 factorial. I can't go too much bigger. So let's say 31 factorial. So you would first put in the 31. You would click on the math key. You would use your arrow key to go to the probability menu, PROB. Well, it depends on what version of the TI-83 or 84 you have. It's either PRB or PROB. And then select the factorial. So let's do that. And let's see if you get the same thing that I get. So do that on your calculator. And if you do not get what I get, then tell me, no, I don't understand what's going on. And we'll do some more until you do understand what's going on. Okay, so let me do this. So I'll type in 31. Then I will go to the math key. After I click on the math key, I will use these arrow keys to go to the probability menu. And then I see that it's the fourth one down. So I can just click on the number 4. And now click on the enter. And it gives me 8.22838.654. And you remember that E, that little E means 10 to the power, in this case, 33. And so let me share back. There. And so using or 85, in fact, approximately 8 times 10 to the 30. So it's an 8 followed by 33 other digits. Okay, any questions about that? So that's how you deal with a factorial using your TI-83, TI-84. Permutations. So in the near future, or you may have already started permutations. So a permutation is actually defined in terms of factorials. It is, well, actually I should probably say that 12p3 is actually, equal to 12 factorial divided by 12 minus 3, 9 factorial. So it turns out that permutations are actually defined in terms of factorials. But, and you can actually, do this calculation on your TI-83/84. But there's actually an easier way of doing it using, well, basically the same thing that we did a minute ago. And so P is actually just times 11 times 10. You start with 12, keep going down like toward, you write out digits, terms in your product. Well, 12 times 11 times 10, 13. And so let's do this. Well, actually, maybe what I'll do is I'll calculate this on my calculator using factorials. And then I will use the TI-83 to do it using the NPR button. So let me do this. So let me calculate 12. Oops. Oh, I went to the wrong thing. No, that's okay. So let me calculate 12p3 two different ways. And so I'll do 12. Okay. 12 factorial. So let's go to the math. Let's go to the PRB menu. Let's go down to the factorial. And then let's divide. So now let's divide here by 12 minus 3, which was 9. Let's type in 9. And then click on the math menu, go over to the ability menu here, and pick the fourth one down. And enter. 20. Another way of doing this. So if you notice, there were a lot of keys I had to hit in order to get to this answer. So if you notice, there are a lot of keys here that I had to go and click on. So let me instead go to type in 12, click on math. So it's the same thing that I did. So it's not going to, be any further than what I've done before. So click on math, go over here to the probability menu. But instead of clicking here, I'll click up here at the NPR. So there's an NPR button here, the second one. But then I got to put in what's down here, the 9. And then I can click enter. Oh, I said 3. You could actually plug in the right thing. That was a typo. A 3. We want a 3. Sorry. I saw a 9 here. And I typed in 9. 3. And type in a 3. And you get 1,320, just like before. And so this is another way of calculating 12.3. And notice it's faster than there. So let's calculate 23. Oops. 23 P14. So do that on your calculator. And so type in 23 into your calculator. Click on the math key over using your arrow keys to the probability menu, and then select the NPR, either by typing in the position, the number of the position, or by using your arrow keys to scroll down to where it is, and then hitting the enter. Type in 14, enter, and then you're done. So do that. And what number did you get? So type in the number that you got in the chat box. Let me see if we get the same number. So 23 P14. Okay, so let me do it. Let me go here and do it. So let me type in the 23. Oops. The 23. There it is. Type in the 23, and then go to the math menu, the math key, and go over to the probability menu and pick the second one down. And then we're doing 23 P14. Type in 14, enter, and we get a gigantic number. We hit 7. 124, 1227, 9 times 10 to the 16. Okay. Okay. Let's do it again. 28 P5. That's such a big number. Let's try that. Okay. So calculate 28 P5 on your calculator. And you do have a TI 8384, correct? You can unmute if you want.
Yes, I have a 84.
Okay, you have 84. Okay, good. Okay. So just type that in. Okay, so what did you get?
Give me 1 second. My someone's getting my backpack for me.
Sure, that's fine.
Okay, what was the numbers?
28 P5. 28 P5.
Mine's looks a little different.
Oh, I haven't done 28 P5 yet. So let's see. You're sharing my screen. Yes. Oh, wait. So let me share my screen here. Let's see if I guess I am sharing the screen. Then why isn't it showing me? Oh, I know why. Okay. So let me type in. I want to do 20.
How did you get that screen to pop up? Is it under catalog? Hello? I'm sorry, I can't hear you. I don't know if it's my end or what, but the whole thing just went quiet.
Okay.
Okay, I have
So
it.
so you can see the screen now, right?
Yes. I see the
Okay.
screen
Okay.
and then I have the probability. pulled up as
Right. Okay.
well.
So yeah. So now you see probability. So once you've gotten to that, then you just select the NPR, the second one down. You can do
Okay.
that by just clicking enter. Of course, I wasn't supposed to do that, but and then let's say, then you would put in the 5, and that'll give you your answer.
Yes. I have the
Okay,
same.
you got the same. Oh, good. Let's do one more. Let's do this. Oh, there it is. Okay. Oh, what was that number? That number was 11
7-9.
7 3 6 0 0. Okay, so now let's do 32 P7. Okay, let's try that. After a while, you'll see that these are all the same. Okay.
Okay. I have 1.6963 91424. And then it has an E
And
then
then
1
is
0.
E 1 0?
Yes.
Okay. That's what I get. So let me see if that's what I get. Go over to my script, my computer, and let's share. Okay, so I want 32. So let me type in 32 first. And then math, go over to probability. And then the second one, and 7. Then hit enter. And yes, I get the same thing. Now, this E means it's in scientific notation. And so what that means is that in this particular case, since it's a positive, that means that this is a very big number. And that means that if I move, that I should move my decimal place 10 places to the right. So it becomes a very large number. Okay, so that's 2, 4, 6, 8. So 4 and then something else. So you would write all those numbers down, plus one other number, I don't know what it is, and that would give you your answer. Okay. Is everyone okay on figuring out permutations? Even though you don't know what a permutation is yet, you'll get that in your course. So this is really just as a preview of how to do it on your calculator. Because when they do it in your course, well, we quickly go over what it is, but we sort of expect that you can quickly do it on your calculator.
Okay.
Let's do a combination. So a combination is actually defined in terms of permutations, and factorials. So 6C2 would be defined in terms of, well, what we did before, or in terms of all of just factorials. So this would be 6 factorial over 2 factorial. And remember, 6P2 in terms of factorials was Well, the 6 factorial divided by 6 minus 2, which is 4 factorial. So in this case, 62 would be 6 times 5 over 2 times 1. 30 divided by 2 is 15. Let me do it on my calculator, like 3 ways. Let's do it using just factorials, using permutations and factorials, and then using, well, the NCR button, which will make our life much easier. But let me see if we can do this first. And so let me do on my calculator 6 factorial. Oops. Sorry. Let me do on my calculator. Sorry again. Let me do on my calculator. 6 factorial. So 6, go to math, go to the probability menu, go down to factorial. Divided by, and this is where people get confused. In the denominator, I'm going to have to put a parentheses. Well, actually, let me do it without a parentheses to show you what goes wrong. So this would be, let's type in at 2. So this won't give you the correct answer. And let's go to math, go to the PRB menu, and the 4th one down. And then 4 factorial. So I'll do a 4. I'll go to the math. I'll go to the probability. And then I'll click on factorial. So lots of work to get a wrong answer. So it's 15 is the answer. So let me actually go and correct it. This is a way to correct your mistakes. You click on the second key, and then enter. That goes back to the previous so now, and to insert parentheses one, and insert the other parentheses. So now it tells us. So in this first case, this takes 6 factorial divided by multiply 4 factorial as the product of these two times 4 together first, multiplying the 6 factorial, and then dividing them. And you get your answer that you wanted, the 15. Okay, so now, that was a little bit of a pain. A lot of keystrokes. Let's use our previous permutation. And so I will write in, this is 6. Go to the math menu, the math key, go to the probability, and hit the NPR button, the second one. 2. And then divide by. Let's divide this by 2 factorial. And so 2, go to math, go to the PRB, and factorial, the 4th one down. And now I hit the enter key, I get 15. Good. Still too many keystrokes. So let me show you how it should be done. But notice, that's nice. That's actually what it is. It's so NCR is NPR over R factorial. But let's figure out how to do it only using one key, only one function, the NCR function. So let's plug in 6, math, go over to probability. And now you notice the third one down is NCR. And we want the second. We want 62. Enter, 15. Good. So now, let's figure out 15C5. So now, let's see. Okay.
I got 3003.
Okay. So you got 3003? Oops.
Yeah.
3003. Good. So notice that it is NPR. Know how to do, you knew how to do PR. The NCR is like, oh, I know how to do that. So it's kind of nice. So let me go back over here. So you did 15, oops, 15, math key, you keyed over to the probability menu, you selected in NCR, you clicked in the 5, and then set enter. So let's do that. And so 15, let me select 15, oops. Go to math, probability, and the third one down, and click 5. Enter. 3003. Good. Any questions about that? One more, just to be sure. Let's say, so let me go. So let me do 25C8. So let's figure out that. Is C8.
It's cutting in and out again. I can't hear you.
Can't hear. Okay. Sorry about that.
It's fine.
So
Keeps cutting in and
calculate
out.
25C8.
Yeah, I got 1 million.
Sure. So
Yeah, I'm sorry, 1,081,575.
okay. So let me do this. So let me go over and calculate this. So we want to do 25 math, probability, third one down, 8. And you get 1081575. Correct. Okay, good. Now, let's do another calculation, because this is actually a calculation that is very common when we actually do these types of combinations and permutations, actually combinations. So let's try to calculate this. So it is something more complicated. It's 15C4 times 5C3 divided by 20C7. So it's actually calculating a whole bunch of these. So let me show you how to do it, and then we'll do another one of these. So let me show you how I would do it on my calculator. So let me go over to my calculator. Did I share screen? No, I don't think I did share screen. Okay, let's share screen. Okay, so let's calculate this. So we actually have several things to calculate. So let's do 15. Oops. 15. Then go to math. Go over to the probability menu. And then NCR. And I want 15C4. Then say multiply by 5. Then go to math, the probability menu, NCR, 3, and then divide by 20. Go over to, math, and then the probability menu, NCR, 7. And then hit enter. And so you get something small. 0.1760 835 913. So you get something that's actually a probability. So you probably have not seen this yet, but this will be a calculation to calculate a probability. Okay, so let me go back over here. Okay, so now, so what you did was you calculated the 15C3, 15C4, multiplied it by 5C3, and then divided by the 20C7. Okay, so, and it would have been much worse if you had to do all these factorials and all that. So this makes it a little bit faster.
What's the difference between NPR and NCR? What is the difference?
Yeah. So they'll explain it in your class. So one has to do with if there's ordering or if not ordered. So if you say you have, let's say, a list, you have 6 books. You have a list of 6 books, and you want to list your top two, or let's say you have a list here of 6 movies. So you're choosing your favorite movies. So there's 6. I give you 6 movies. Pick in order your top 2. Your top one and then the second one. That would be permutation. In a combination, order doesn't make any difference. So from a list of, say, I have 6 students, and I want to choose 2 of them. And I don't care which one I choose first or whatever. Let's say I'm choosing students to be on a basketball team or something. So I don't care which one, or whatever, to be on, on something. So I don't care which one I choose first or second. So if order doesn't make any difference, then it's a combination. Okay. So, but they'll be going over, that in class. So in class, we'll be discussing difference in permutation combinations. But for right now, I'm mostly just telling you how to do it on the computer, on your calculator, so that you can figure that out. So let's do another one. Let's do 23, choose 6 times 7, choose 3, divided by 30, choose 9. So now you get to do that. This is actually this is again a probability. So do that on your calculator and see what you get. Oh, let me do.
469.
469. Oops. 469.
And 496021.
Okay. So let me do this on my calculator. Oh, let me.
There's a 2 at the beginning. 2469.
Oh, there's a 2 before this?
Yeah, no, it's 0.24.
Ah, okay.
Yes.
Okay. Okay. So let me do that. And actually, let me go here before. Okay, check in students. So let me check you in. Okay. That's it. Okay. Okay, then. So let me check you in. Okay, so let me do this on my calculator. On my TI. Oops. Let me do this. So there it is. Okay, so let me try to calculate this. So I have here 23. Go to math, probability, pick Ncr, and we want 6. And then let's multiply this by 7. Go to the math and the probability menu, then Ncr, and 3. And then let's divide by, go to math, oops. Not that it really matters, but let me go to, let's put the number in first, 30, and then math, go to probability, NCR, and then 9, and hit enter. 24, 69, 49, 60, 21, correct. Exactly the correct thing. Okay, good. So that's how to do. Okay, so that's really what is necessary, at least for you to know on your calculator for probabilities, that chapter on probabilities, chapter 4. Before I go on to, well, discrete distributions, any questions on anything related to your calculator, the TI-83, 84?
I did have one. I'm trying to pull it up.
Okay,
I'm not sure exactly how I would explain it. Give me one
sure. Do
second.
you want to share your screen?
I can. I'm on my phone, so I would have to do like a just turn on my video and show it.
Okay, if you wish to, you can do that. Yes,
Okay, let me see.
I'll probably have to stop sharing screen. Okay, so you have here, use the data, film randomly selected. If 3 different orders are selected, find the probability they're all from restaurant B. Okay, so if you look here, so the question is, how many in total without replacement? Okay. So you're going to be, so you're doing this without replacement. Okay, so.
So I got the
So
other one
let's see.
correct. I just without replacement. I'm not quite sure how to do that.
Okay, so let me ask you. So how do you do it with replacement?
With replacement, I just kept everything the same. I didn't take out any of the orders. So
Okay.
but without replacement, I took 3 out of the total of numbers. So I added all of those numbers together. And then I
Yes.
took out 3, and then I did the multiplication for it, and that's how I got 0.23, and I rounded it. But
Yes.
it said it was incorrect, so I don't know if I took
Right.
out the 3 in the wrong location.
Well, right. So you would do it sort of the same way. Okay. It's just that, so notice what you did is you multiplied the same number 3 times, right?
Yes.
Okay. Now the only difference is, so how many, well, let me ask you, so how many in total are there? How many restaurants in total?
There's 3 restaurants, A, B, C,
No,
D.
no. Right. Okay.
So there's 4 restaurants.
Right. But it says, okay, so how many orders in total?
Um,
So you'd have to add those all up, right? I've copied it correctly, the numbers here. Okay, so you want to find the probability that 3 of them were all from restaurant B. So the first thing I want to do, actually, let me.
yeah, it wants me to, and I'm getting, and it says assume that the orders are selected without replacement. So I don't know if it means
So let's do the following. Let's add up a whole bunch of things before we do anything. Let's add up a whole bunch of things. So let's add up, this total too. Let's add up things first before we do anything. So let's add up. 7 plus 7, 14. 51. 62. 70. Let's add up the other way. And so
197 orders total.
197. Okay, so let's see. This is going to be 50, 85. this is 34, 64, 70, 86. Okay, good. Okay. And let me just check again. That's 65, 67, 127, 197. Good. Okay, so now let's figure out the probability that 3 of them are from B. So first question is, so I'll do it this way. I want to figure out the probability that the first is from B. And then the second is from B, etc. Okay. So let's do that. So what's the probability that the first thing that I choose is from restaurant B? Well, how many in total orders are from restaurant B? 51. So 51 out of the 197 are from restaurant B. This is the number of orders that were accurate, and these were the total number of orders that were not accurate. So the total number of orders is 51 from restaurant B. And there are a total of 197 orders. Now, I'm going to put him aside. So now I already chose one of these from restaurant B. So now, after I've done that, how many total orders are available from restaurant B? I've already chosen one of them. So there has to be one less of these. Only 50 of them. And not only that, the one order from restaurant B made this guy one less. Okay. And then, well, let's do it again. So so for the first one, there were 51 orders. But after I choose one of the orders from restaurant B, there were only 50 remaining orders that could have been from restaurant B. For now, well, how many orders are available, for the third time? Well, how many will be available?
It'll be 49, right?
You'll be 49. How about for how many total are available?
195.
195. And that's your answer. You can multiply these together. We'll do it 2 ways, I guess. Or notice this is actually 51p 3. And this is 197 p3. You can do it either way. So let's do it on our calculator and calculate this. So let me share my screen.
So 51p3.
Yeah, it'd be 51p3.
All right, I have 124,950.
Oh, but then you have to divide it by the 197 p3.
Oh, okay. I have 0.01659,508.
Okay, so let me do this. I'm actually going to do it two different ways. So I'm going to first do the 51 over the 197. So let me do that. So let's do the 51 divided by 197 times the 50 over the 196 and 49 over 195. And you look, oops, and we will get the same answer. And so I got 0.203, 203, 289.
50 by 16.
Oh, you stupid jerk. Thank you. And you get a wrong answer because 196. Thank you. Okay, so, and you get something different. And so, and you get 0, 1, 6, 5, 9, 0, 8. Let me see if I wrote it down now. Now I'm really paranoid. 51, 52, 49, 695. Okay, good. Okay, so, or you could do 51, math, probability, go to NPR, and there were what, 3 numbers there? Divided by 197, math, PRB, second one, and it is 3 again. And voila, you get the same number.
Yeah.
Okay, good. So, and you notice that actually, well, in this case, it's almost the same amount of work. Actually, in this case, it's about the same amount of keystrokes, just because to get to the NPR took a while. Okay, good. So that's your answer. And then you probably have to round to a few decimal places. It's probably 0.02 or something is what they wanted. Okay?
Mhm.
So that's how you should do that.
Okay.
Any other questions?
No, that was the only question that I was kind of confused on is the without replacement. I didn't quite understand.
Right. Yeah. So notice if you did it with replacement, let me go back over. It wouldn't change that much, right? The only difference would be, the only difference in the calculation would be that you would have 51 over 197 cubed. That would be the only difference, right? Because you'd be multiplying the same number over and over and over again. Let me just see what you get in that case. Let me share my screen. And so let's do 51 over 197. And then you would bring it to this exponent here, power 3. And you would get
Not the same thing.
almost 0. They're going to be close.
Mm-hmm.
0, 1, 7, 3, 5, 0, 4, 9, 2. So they're not exact, but they are pretty darn close. I mean, to 2 decimal places, they're the same. The 3 decimal places, actually, they're the same. So the 3 decimal places, they're the same. So they're pretty close to each other. They're not, identical, but they're pretty darn close. Okay, good. So no other questions. Even on any of the previous calculations, say with means, median, mode, or anything with a TI-84. Any other questions before we go to the next topic?
No.
You're good with all those. Okay,
Yeah.
good. So you're good with that. So let me share my screen over here. Okay, so let me share my screen. There. Okay, so the first topic I'm going to talk about are discrete probability distributions. So when you have word problems involving discrete probability distributions, you're going to have to be able to translate some words. And so if you see the word more than, it means the symbol greater. At least means greater than or equal to. Exactly equal. No more than means less than or equal to. So a lot of times the error that students have is that when they see no more than, they make a less than, but it's actually a less than or equal to. At most, less than or equal to. Less than is this less than symbol. Not more than. Less than or equal to symbol. Not less than. Greater than or equal to symbol. Greater than, well, it's the more than symbol. Not greater than, the less than or equal to symbol. No greater than, the less than or equal to symbol. And fewer than, the less than symbol. So these are the popular phrases that you need to sort of memorize what these symbols mean. Or, well, what these means in terms of these inequality symbols. Okay? So, once you know these, now let me do some examples of how, how you would use your TI-83, TI-84 to calculate something called, well, a binomial distribution. So probabilities involving these binomial random variables. So in order to calculate a probability involving a binomial random variable, it turns out I need to know something called N, the number of trials, and P, the probability of success. So let's consider the case where I have a binomial random variable where N here is 7 and P here is 0.2. And I want to figure out the probability that X is identically equal to 3. Then to calculate this, I would do, well, it is 7. So you do 7, choose 3, because there's a 3 there, times P, which is 0.2, to the power 3, times the complement of this P. So if 20% are successes, then 80% are failures. And so this is, well, the number, the probability of a failure times, well, 7 minus 3 is 4. So let's calculate that on our calculator. Then we'll actually use the, well, there's an actual key to calculate this. So let me do this. Let me go over here. Okay, so let's first do this by hand. So let's plug in 7. Go to math, the probability menu, and the third one down. And so that's NC, and then R in this case is 3, times, oh, I don't care. I'll put, yeah, times, just to be sure, 0.2 to the power of 3 times 0.8 to the power of 4. You actually don't need these multiplications here, but then it makes everything look a little weird. You enter, so you get 0.114688. Now, let me use the TI-84 to actually calculate this. So let's go to the distribution key. So I have to notice this is above the variables key. So I'll have to click on second, and then this vars key. Now it gives you a whole bunch of things. And I want to go down, so I keep scrolling all the way down, or I could scroll from the bottom. It's actually closer to the bottom than top. So I'll scroll from the bottom and find the binomial distribution. So here it says binom. So that's a binomial distribution. And now there's 2 choices, NPR and NCR. NPR is when we have an equal. I wanted to find the probability X equals 3. So I use NPR. So choose that. The number of trials was 7. The probability of success was 0.2. And we wanted to find when X was 3. And so we have binom PDF 7, 0.2, 3. And I get 0.114668. Okay. So let's do another example. Okay, so let's suppose n equals 12, p equals 0.35. I want to find the probability that x is equal to 7. So I want to determine binomial PDF, P because an equal sign, of 12, and the number of trials is 12. The probability of success per trial is 0.35, and the number of successes that we want is 7. So do that on your calculator, and then I will check.
I got 0.0591 246081.
Okay. So let me do this on my calculator. And so I have distributions. Go to binomial PDF. I have 12 trials, 0.2 probability of success. No, 0.35. Look at the wrong thing. 0.35 probability of success. And I want 7 successes. 0.059, 1246, 081. Correct. Okay, good. Now, let's go back here. Complications. Okay, so now let's do it for inequalities. Okay, so now suppose we have the same thing. So I'm not going to change that. Again, suppose I have n is 12, p is 0.35. But now suppose I want to find the probability that x is less than or equal to 7. So now, the only difference is, instead of putting a PDF here, I'm going to put a CDF. So only difference here is CDF. So it's going to be a binomial. So when you select the same thing you did from before, your selection should be CDF rather than PDF. So do that. Let me see what you get.
I got 0.97 4492 543.
Okay, so let me do that. So share my screen. And so let's do distributions. Go to binomial CDF. That's the only difference. Number of trials, 12. Probability of success, 0.35. And we want less than or equal to 7. Yes. 0.97449243. Now, let me go back. Okay, good. So I'm going to change this. Now suppose I want to figure out the probability that x is greater than 7. Now it's a complication because whenever using CDF, and this is true for any of the CDFs, so the PDFs, so maybe I should actually write this down here, that when you do PDFs, it's always when it's equal. CDFs are always less than or equal to, which means that if you have any of these cases where it's not, less than or equal to, then you have to switch them so that they become a less than or equal to. So in this case, I want to find the probability x is greater than 7. So what's the opposite of greater than? So let's see, what's the opposite of more than? Less than or equal to. So the opposite of more than is less than or equal to. So this becomes 1 minus probability x is less than or equal to 7. So what you have to do now is do a 1 minus, and then plug this in your calculator. So you're going to do, oops, I should probably do more of these examples. So let me do this on my calculator. Okay, so I'll do 1 minus, and this will be a CDF. So I'll go to second, distributions, go to binomial CDF. The number of trials was 12.35, and it is 7. So if you do that, you get 0.0255 07457. Okay. So switching over. Suppose, I guess let's let n is 12, p is 0.35. Suppose I want to figure out the probability that x is greater than 3. Calculate that. So now I'm going to let in here still be 12, p still be 0.35, but I want to find the probability that x here is greater than 3. So you're going to have to do the complementary event. Find the probability for the complementary event.
So it's still the same. It's just we're changing 7 to 3.
Yes, it'll be 1. That's correct. So everything will be the same commands. It's just instead of having a 7 here, you'll have a 3.
Okay. So the answer I got was 0.6533 473,038.
Okay, so let me do this. And so I want to find the probability X is greater than 3. So I want to take away the first 3 of these. So let's do 1 minus. Second, go to distributions, scroll till you find binomial CDF. And so we have 12. Number of trials is 12, probability of success 0.35. And we want to get rid of those first 3. And then what remains is, well, so I'm going to get rid of the probability X is 0, probability X is 1, probability X is 2, and probability X equals 3. So what remains is, well, all the numbers bigger than 3. 0.6533473038. Good. So now, further complications. So let's go here. So how else can I vary this? Okay, so we had greater than. Now, let's do the probability X is greater than or equal to 3. Okay, so now, well, this is going to be 1 minus the probability X is less though. So if you notice, when I switched it around to give me an equal, I had to have a greater than. So X greater than or equal to 3, well, what is it greater than? Give me a number here so that if I put, same number here like 7, then X greater than 7 is the same as saying X is greater than or equal to 3. Well, what number should you put here? Two. Because if X is greater than 2, well, what are numbers, what are integers greater than 2? Well, 3, 4, 5, etc. Oh, it's these numbers. And now, see this little complication. So now you'll do the opposite. So if you want to figure out the probability X is greater than or equal to 3, then you do 1 minus the probability X is less than or equal to 2. And that's exactly what we just did up, or what we did up here, this calculation. So do that.
Okay, for that one I got 0.8487124217.
Okay, so let me do this. Let me go and do this. So I want to figure out the probability that X is greater than or equal to 3. So I do 1 minus. So I found complement. So being greater, what's the opposite of greater than or equal to? And so it's less than 3. So What are numbers less than 3? Well, those are things that are less than or equal to 2. So let's go to distributions. Let's scroll till I find CDF. And so again, 12 trials, yes. 0.35, yes. And I want to get rid of the first 2. If I get rid of the 0, 1, and 2, then what remains is what I want. 0.84, 87, 124, 217. Okay. So now let's go back. So I didn't do less than. There are all these variations. But once you find one of them, then all of them remain the same. Okay. So now let's do the probability. Let's say x is less than 3.
For
Well,
this
what's the
one, it'll
probability?
be the, oh, I'm sorry.
Yeah. Well, no, continue what you said. Yes.
Oh, no, I was gonna say for this one, since it the sign changed, would it be
Mhm.
the PDF or would it still be CDF?
It'd still be CDF. It would still be CDF. It'll only be PDF if this is an equal sign.
Okay.
So now you've got to translate this into, well, something where it has an equal sign. So it's a probability. X is less than or equal to 2. So in this case, X being less than 3 is the same as X being less than or equal to 2, right? If you have here 0, 1, 2, well, those are all numbers less than 3. And so here you don't have to take the complementary event. So let's plug that in. So you just plug in, well, the same way you did this one here. It's just in this case. So it's just a straight CDF. But you put in 2 instead. Okay. So what did you get?
Are we trying to find the value of 3 or of 2?
2.
2. I got 0.1512875783.
Okay, so let me do that. Okay, so I'll just find binomial CDF. Number of trials was again 12.35. Oh, and you wanted 2. Oh, so everything's the same here. So 0.1512875,783. Okay, good. So let me go back to, so now that you've done that, everything else remains the same. There's really not any variation. It's just now plugging in for the particular discrete probability distributions. So there's something called a Poisson distribution. And so for a Poisson distribution, there is some parameter here, mu. And so let's suppose that our parameter mu is 0.4. Then the probability x is 3 would be, well, you plug in 0.4 to the power 3 over e times e to the minus 0.4 over 3 factorial. So let's do that on my calculator, see what I get. And then I'll show you how to do it. Almost identical to what you did with the binomials. It won't really be any different. So let me share this. So first, let me show you how to calculate 0.4 to the power 3 e. So you'd go the second, see there's an e here. So you go second, right above the ln, e to the power negative. Never use this, or you get an error. Negative 0.4 divided by 3 factorial. So 3 math probability factorial. And you get 0.071500,805. Now, I can do the following. I can use my distributions. So second, in this case, I want to go to Poisson. That's even closer to the bottom. I want it PDF because it's an equal. Oh, they use lambda instead of mu. Lambda 0.4 or mu. My x value was 3. And so it's Poisson PDF 0.4 comma 3. And you get the same answer. Okay, so now let me go back here. And ask you. Here it is. Now let mu be the same thing. Let or lambda. I don't care what they are calling it. Let mu or lambda be equal to 0.4. Suppose I want to figure out the probability that x is less than 5. Do that on your calculator. Oh, wait. No, less than or equal to 2. That's right. That's right. Okay. So now that you know how to do it using, well, for the binomial, you should do it the exact same way. So use your knowledge from the previous to see if you get it. Good, only 10 minutes. Okay. So what did you get?
I'm not sure I'm doing this right. I got
Well, let's see.
5.72006439 the letter E, and then -5.
Yeah, because it's a small number. Okay, that's probably, it's a PDF. Ooh. Ooh, let's see. Let's see. Okay, so let me go over and do it. Okay, so I have here that x is less than 5. Well, what's the integer that's less than or equal to that? What's the next integer smaller than 5? 4. So what I should do here is do Poisson CDF, it's an inequality. In this case, mu is, or lambda is 0.4. And I want not 5, but 4. I got a different answer than you got. And so what I got was and maybe I'll put this in here, 0.999 983 7567. Okay, so let me go back for a second over here. Let me go back here. So I really wanted to calculate. Remember, everything's got to be rewritten in terms of less than or equal to. And so, less than 5 is the same as less than or equal to 4. Okay? And so the number I put in was 4, and there was a inequality. So for inequalities, you use CDF and not PDF. So I think you probably put in PDF because it was a small number. Yeah. So let's do another one. Let's do the probability that x is greater than 7. So use the knowledge you had from the binomial to see how you can change this. Because it has to be a less than or equal to.
So would it be would it be 6? I would put 6 into the calculator instead of 7?
No.
No?
You do 1 minus Poisson. So you put in 1 minus, and then everything would be the same except you'd plug, it'd be a 1 minus Poisson CDF. You'd have a 0.4 for lambda or mu and a 7 for your x.
Okay, I have 1.13997 e negative 8.
Okay, it's a small number. And let's see. So in this case, I'm going to do the complementary. So I want to get rid of the first 7 numbers. Because if I get rid of the first 7 numbers, then what remains is everything that's greater than 7. The first set, well, not the first 7 numbers, but the numbers 7 and below. I want to get rid of the number 7 below. And so Poisson, CDF, 0.4, 7. Yep. And so again, the little e means that it's in scientific notation. So this is times 10 to the power negative 8. So if you look here, the way that you would write it on your paper, when you would report the number, is you would not write the E. So you would not write E, but instead you would write times 10 to the power of what they gave you, the -8. So you do not write the little E there. You write this. Okay, let's do another one. Probability X, well, this is going to be really big, is less than or equal to 7. So do that one.
It would still be -1 at the beginning, correct?
No, actually, no.
No. Okay.
This is actually straight.
Okay, I got 0.999 oh goodness, 999 9 again, and then 886.
Yeah, that looks correct. So that looks correct. So let's do this. Lots of 9s is the answer. There are like 8 of them, or 7 of them, and then yeah, 7 of them. Okay, so I'll just do distributions, Poisson, CTF, and actually everything's right there. So 999,886. Okay. And let's do one more of these. And so, oh, wait, I am not sharing my screen.
How would you round a number like that?
Oh, it tells you how many. He would round to 1. Unless it's more than 8 decimals, it would probably round to 1.0, whatever. So let's say if you want round to the to 2 decimal places, it'd be 1.00. So you would actually write it. Let's say you want to round it to the nearest hundredth, and you'd have to write those zeros there to indicate that it's been rounded to this decimal place.
Okay.
Okay. So yeah, because this is pretty darn close to 1. So it'd be like to 2 decimal places, it'd be 1.00. Okay, let's do one more of these. Let's say greater than. The probability X is greater than or equal to 7. So now, again, you have to retranslate it into a less than or equal to.
Okay. And this one, I want to have to -1, right?
You're going to have to do 1 minus, yes.
Oh. 1 minus.
Because you want the complementary event.
Then, okay, I got 2.2930,691 e -7, so times 10 to the power of -7.
That is correct. Okay, so let me look. Okay, so in this case, I want to find the probability x is greater than or equal to 7. And so if I get rid of everything less than or equal to 6, then that will be, then what remains is everything greater than or equal to 7. And so I'll do 1 minus, go to distributions, go to Poisson, CDF. Lambda is still 0.4. And I want to get rid of the first 6 of these. Well, for everything less than or equal to 6, what remains is everything greater than or equal to 7. 2.2930691 times 10 to the -7, correct. Okay. It's actually, we started at 3, so it's 5 o'clock. Okay, so I guess that's it for today. All the other ones I was going to go over, they're all similar. So using this idea, you should be able to do it for, just change the name. Notice that these were the same as the binomial. You just had to really just pick something, right next to it that had the same name. Okay. So I guess that's it for the workshop. It's 5 o'clock. Any questions about anything?
No, I think I can I have it pretty much.
Sorry about that.
Understand.
My other computer died. Any questions? Let's see, can I hear you?
No, I don't have any questions.
Okay. If there are no questions, then I guess that's it. And thank you for attending.
Thank
Okay,
you.